A silent transformation is underway, one that threatens to unravel the rhythms of the planet as we know them. Nearly 2 billion people are standing at the edge of a climate rupture that could make entire seasons unrecognizable, rivers undependable, and farms unsustainable. The culprit? A shifting atmospheric band that holds the pulse of the tropics in its grasp. At the center of this story is the Intertropical Convergence Zone, or ITCZ, a seemingly invisible line, yet one of the most powerful climate engines on Earth. It's now showing signs of displacement, and the warning signs point to a future locked into chaos. On May 14, 2025, a landmark study was published in the journal Earth's Future. Led by climate scientist Norman Steinert of the Center for International Climate Research, Cicero, in Norway, the research tapped into next-generation climate simulations and explored a haunting scenario. What happens if global temperatures rise 1.5 degrees Celsius above pre-industrial levels, even for just a short period? The results paint a grim picture. Even a temporary overshoot could force the ITCZ to shift and not return. This subtle line circling the equator could leap southward, pulling the rains with it, redrawing the boundaries of habitable land and reshaping the fates of nations. To understand why this matters, you need to understand the ITCZ itself. It's more than a band of storms. It's the engine room of the tropics. It's where trade winds from the northern and southern hemispheres meet, pushing moist air upward into massive columns of storm clouds. These rising towers of vapor fuel monsoons, tropical forests, and rivers that nourish nearly half of Earth's population. When that band moves, when it drifts by even a few degrees of latitude, the consequences are profound. In some regions, monsoon seasons might arrive too late or not at all. In others, torrential rains might saturate soils for months, breeding disease, flooding cities, and rotting crops in the field. The stakes are highest in the tropics. In West Africa, for example, farming systems depend almost entirely on the reliable onset of rains. If the ITCZ lingers too far south, planting seasons are lost, harvests wither, and millions go hungry. In Southeast Asia, rice paddies rely on steady downpours. Without them, both the food supply and rural economies collapse. In the Amazon, the ITCZ helps feed one of the most complex ecosystems on the planet. If that rainfall shifts or vanishes, entire forest systems may degrade into savanna. That, in turn, would release vast quantities of carbon, accelerating global warming and creating a vicious feedback loop. But these disruptions go far beyond agriculture. In equatorial regions, rainfall determines everything, from water quality and hydropower generation to the timing of disease outbreaks. In places like the Congo Basin, even small changes in precipitation can alter the flow of the world's second-largest rainforest, impacting not only biodiversity, but also atmospheric circulation patterns across entire continents. Add to that the cultural and societal importance of seasonal rainfall in many regions. Rituals, agricultural calendars, and even school schedules in parts of the world are synced with the seasonal movement of the ITCZ. A shift in this ancient rhythm is not just a meteorological event. It is a disruption of human tradition, social organization, and long-standing relationships with the land. The impacts won't be evenly distributed. Some regions will drown while others will dry to dust. Northern parts of South America, Central Africa, and South Asia are particularly vulnerable, where rainfall patterns are tightly coupled to the ITCZ's position. The displacement of this zone by even a few hundred kilometers could destabilize food systems serving billions. This isn't a theoretical exercise. The study draws on real data rooted in paleoclimate records that show the ITCZ has shifted before, during ice ages, volcanic eruptions, and solar cycles. But never has it moved this fast, and never before due to one species' impact on the atmosphere. In fact, the fossil record reveals that massive climate shifts linked to ITCZ movements have triggered collapses of entire civilizations in the past. From the abandonment of ancient Mayan cities to prolonged droughts in the African Sahel, history is filled with warning signs that humanity has long been vulnerable to disruptions in rainfall. The study's simulations modeled various emissions scenarios. In the worst case, where warming peaks above 2 degrees Celsius, the ITCZ doesn't just wobble. It snaps southward and stays there for centuries. Even in more moderate projections, the changes are still large enough to be considered irreversible on human timescales. Why can't it just snap back? Because the Earth's climate system contains inertia. Oceans store heat. Ice sheets melt slowly. Carbon dioxide lingers in the atmosphere for hundreds of years. Even if emissions stop tomorrow, the ITCZ could remain off balance for generations. And in the meantime, society will be forced to respond in real time. Countries will face decisions about resettlement, emergency food imports, new water infrastructure, and shifting agricultural zones. Migration pressures may rise. Water wars could become more than speculative fiction. Fragile economies may unravel under the strain. The consequences won't respect borders. Droughts in one region could ripple across global markets, causing food prices to spike thousands of miles away. Insurance systems could fail under the strain of repeated climate shocks. And political instability could follow, as governments face unprecedented stress on already vulnerable systems. This means policy decisions today are shaping the weather for the children of the 22nd century. What we decide in boardrooms, parliaments, and living rooms over the next few years may lock in climatic disruptions that no future technology can fully reverse. The researchers emphasize this is not doom yet. We still have agency. Rapid emissions reductions, aggressive reforestation, cleaner energy systems, these aren't abstract hopes. They're the lifelines that might stabilize the system before it tips. But action requires understanding. The ITCZ is invisible, yes, but so is oxygen. And just like oxygen, we depend on it far more than we realize. It decides when the rains arrive, where crops will grow, whether deserts will expand, whether rivers will run. Think of the world's water systems as an intricate ballet. Streams of vapor, jet streams, cloud formations, trade winds, solar angles, and ocean currents moving in a delicate choreography. The ITCZ is the choreographer. Without it in the right place at the right time, the dance falls apart. As the ITCZ shifts, climate instability may trigger mass migrations. Millions of people forced from their homes not by war, but by the absence of water. Cities built on riverbanks could find their lifelines drying up. Economies based on farming could collapse under prolonged droughts or sudden floods. This is the kind of systemic risk that cascades. When one region's crop fails, global food prices rise. When coastal communities flood, insurance systems strain. When rainforests dry out, more carbon enters the sky, feeding the very problem that started it all. We are standing on the edge of a planetary reconfiguration. This isn't just about rainfall, it's about rhythm, stability, survival. The ITCZ has kept its beat for millennia, but now it trembles. The choice ahead of us is stark. Allow it to shift permanently, or act urgently to keep the balance. Subscribe to this channel to stay informed on the science that shapes our world, because understanding the storm is the first step in weathering it.